Apache Kafka. Understanding the complete architecture. Welcome to a comprehensive breakdown of Apache Kafka's distributed streaming platform. Let's explore how Kafka's components work together to handle millions of messages per second across enterprise applications. The foundation. Producer and topic. Our journey begins with the producer, the data source that publishes messages to Kafka. Think of producers as data generators. Web applications logging user activity, IoT sensors sending telemetry, or microservices. Communicating events. These producers send their messages to topics, which act as named channels or categories for organizing related data streams. A crucial aspect of topics is their flexibility. A topic can have 0 or more consumers. This means you can create topics preemptively, waiting for future consumers, or have highly popular topics serving dozens of different applications simultaneously. Consumer architecture, individual and groups. On the consumption side, Kafka offers 2 consumption patterns. Individual consumers can subscribe to 1 or more topics directly, giving them access to all messages. However, the real power emerges with consumer groups, collections of consumers working together to process messages from topics. Here's where Kafka's scalability shines. A consumer group contains 1 or more individual consumers, and the system automatically distributes the workload among them. If one consumer fails, others in the group seamlessly pick up the slack, ensuring continuous processing. Partitioning, the scalability secret. Kafka's horizontal scaling capability comes from partitions, subdivisions of topics that enable parallel processing. Each partition maintains an ordered sequence of messages, and each partition has exactly 1 consumer per consumer group. This design ensures that message ordering is preserved within partitions while allowing multiple consumers to process different partitions simultaneously. The beauty of this architecture is that a consumer can pull messages from 0 or more partitions, providing incredible flexibility in workload distribution and fault tolerance. High availability through replication. Kafka ensures data durability and availability through its replication system. Every partition has a leader replica, the authoritative copy that handles all read and write operations. Supporting the leader are follower replicas that continuously synchronize with the leader's data. Each partition maintains 0 or more follower replicas, creating redundancy that protects against hardware failures. When a leader fails, one of the followers automatically promotes to become the new leader, ensuring uninterrupted service. Cluster and broker infrastructure. At the infrastructure level, Kafka operates as a cluster consisting of 1 or more brokers, the server nodes that store and serve data. Each broker hosts multiple replicas, distributing the storage and processing load across the cluster. This distributed architecture means that each replica exists on exactly 1 broker, but the cluster's intelligence ensures optimal placement for performance and fault tolerance. Brokers can join or leave the cluster dynamically, with Kafka automatically rebalancing data as needed. Real-world applications. This architecture makes Kafka ideal for real-time analytics, processing millions of user events per second, microservices communication, reliable message passing between services, log aggregation, centralizing logs from distributed applications, stream processing, building data pipelines that transform data in real-time event sourcing, maintaining complete audit trails of system changes. The power of Kafka's design. Kafka's genius lies in how these components interact. Topics provide logical organization, partitions enable horizontal scaling, consumer groups ensure fault tolerance, replication guarantees data safety, and the broker cluster delivers the infrastructure to support it all. Whether you're building a simple event-driven application or a complex real-time data platform processing terabytes daily, understanding these fundamental concepts, from producer to cluster, gives you the foundation to harness Kafka's full potential. This architecture has made Kafka the backbone of data infrastructure at companies like Netflix, LinkedIn, Uber, and thousands of others who need to move data reliably at massive scale.